2.4, reasoning with properties from algebra. All right, so the first few, they basically are giving you one of the properties, and it wants you to say, like, because of the property, why we can do what the, like, if-then statement is. So number 10, the symmetric property. And it's of equality. I'm just shortening it. If the measure of angle A is equal to the measure of angle B, then blank. So what does the symmetric property tell us?
Measure A equals measure B, then measure B equals measure A.
Yep. So then we would write the measure of angle B is equal to the measure of angle A. Why is this doing 12. Substitution property. And I don't mind you abbreviating things when you're doing these. Just what I would tell you is subtraction and substitution, you're not really going to be able to abbreviate because they would have the same abbreviation. So if LK plus JM is equal to 12 and LK is equal to 2, then blank. What has to be true? We already know LK is equal to 2.
JM is equal to 10.
Oh, wait. Oh.
JM is equal to 10. So basically we would have 2 plus JM is equal to 12. So JM is equal to 10. Now you could have just gone straight to this part here. I just wrote this so that we can see how we got that. All right, the next few problems want us to solve the equation and state the reason. So basically why we're allowed to do the step that we're doing. So 16, p minus 1 is equal to 6. So this is my given. So if I'm trying to solve for the variable, because that's what they want me to do, I would add 1, so I would get p is equal to 7, and that is the addition property. So abbreviating it like that is fine. If you look in the book, it's going to say of equality. If you don't write the of equality part, that's fine. I'm not going to be picky about that. 18. 2r minus 7 equals 9. So that's my given. What would I do next?
Add 7.
And what allows me to do that?
Addition property.
Yep, addition property. So I have 2r equals 16. And then what would I do next? Divide by 2. So r is equal to 8. And what allows me to do that? Yep, division property. (22) 26u plus 4 times 12u minus 5 equals 128. So when you write this, obviously I'm writing the problem statement, right? That's what I've been doing. So if you do that, instead of having to rewrite it and write given, you can just write given beside it like I've been doing. I just want to specify that that's what we're doing. Do you have a question? All right, so after that, what would be the next thing that I need to do to start solving this equation?
Distributive.
Yep, distribute for the parentheses. So I would have 26u plus 48u minus 20 equals 128. And so that would be the distributive property. What would be the next thing that I would do?
Combine like terms.
Yep, so 26 and 48 is going to give me 74u minus 20 equals 128. You can combine like terms is a little bit longer. If we just say simplify, it's something that's shorter, but either way, like I said, would be fine. Then what?
Add 20 to 128.
Yep, so I have 74u equals 148, and I can do that by the addition property. And then what's the last thing I need to do?
Divide.
Yep, so I get u is equal to 2 by the division property. So when we get to quizzes and tests for this stuff, okay, I'm going to be looking for, okay, did you solve the problem correctly? And then did you give the correct reason? Okay, so it's going to be kind of multiple things here that are giving you your final answer. Now, there's one thing that I would note here. Right here, after I did this, I combined my like terms and simplified it. You could have also waited to do this and went ahead and added the 21st. As long as you have all the steps there and in a logical order, that's fine. We just normally simplify first and then we move on. But if you had flipped those two things and say added it over first and then simplified, that also would be okay. But you can't do, unlike in Algebra 1, you can't do multiple things at the same time. We have to do it like one at a time, okay? Let's see. All right, 24. So this one, they've already done all the steps for you. We're just going to be saying why we can do those steps here. So in number 24, they give you a diagram, which I'll draw over to the side in a second. But they tell us that the measure of angle RPQ is equal to the measure of angle RPS. Verify each step in the argument that shows that the measure of angle SPQ is equal to 2 times the measure of angle RPQ. And basically, I've got something that looks like this. Like that. This is P, S, R, Q. All right, so the first thing, let me go back. This is all given stuff that given. They give you the statements, and then we're going to write the y's behind them. So the measure of angle RPQ is equal to the measure of angle RPS. What would be the reason for that? Given, yes. All right, the next thing that they tell us is that the measure of angle SPQ is equal to the measure of angle RPQ plus the measure of angle RPS. Anybody know what the reason for that would be? You might have to look back to stuff from chapter 1. I think it was in in chapter 1.
Angle addition postulate.
Yep, angle addition postulate. All right, the next thing that they tell us, or what their next step was, is that the measure of angle SPQ is equal to the measure of angle RPQ plus the measure of angle RPQ. Any idea what the reason for this would be? Or what did I do in this statement? I went from measure of angle RPQ plus the measure of angle RPS to the measure of angle RPQ plus the measure of angle RPQ. And I was told at the beginning that the measure of angle RPQ is equal to the measure of angle RPS. So what did I do? Huh? No. How did I replace this with this? Starts with an S. Substitution. And then their last statement is that the measure of angle SPQ is equal to 2 times the measure of angle RPQ. What allows me to do that? No, that's what we were trying to prove. So the nice part about geometry is they tell you something to start you with. Then they tell you what the end result's supposed to be. You just got to fill in the middle. How did I get from here to here?
Squared it. You made it.
Do what?
You made it to distributive.
Yep.
So
Exactly. Distributive property. Okay, so it's going to take some getting used to of how to do these and how to find the reasons, but that's why it's going to be doing a lot of problems and doing repetition and making sure that you're familiar. Even though you have your theorem and postulate book, you need to make sure that you're really familiar with the stuff that's in there so that you're not sitting there and having to flip through pages and pages every single time you do a problem. Okay? All right, sometimes they give us a statement in if-then form. So they gave us in 26, if angle 1 and angle 2 are right angles. So that means each one of them individually. Then they are supplementary.
you need angle 2 if
Where'd it go? All right, so
is that a cookie?
no. It's not a mathematical mistake. All right, so statement and reason. So the first thing is angle 1 and angle 2 are right angles. So I'm going to write that. And to shorten and not have to write angles out, if you do like an angle symbol with a little s like kind of inside of it, that's an abbreviation for that. So that would be a given statement. And I'm trying to get to the conclusion, or what I'm trying to prove is that they are supplementary. So, if they are right angles, what does that mean about their measure?
They're 90 degrees.
Yep, so the measure of angle 1 is 90 degrees, and the measure of angle 2 is 90 degrees. This is the definition of right angles. So, now I can conclude this and say angle 1 and angle 2 are supplementary. Why? Do what? Yep, which is the definition of? Nope. Supplementary. Definition of supplementary angles. All right, one last problem that's going to be like the Talladega problem that we looked at in the PowerPoint, number 28. So it says some facts about the maximum banking angles of of Daytona International Speedway at corners 1, 2, 3, and 4 are to the right, which is what I'm going to write down in just a second. Find the measure of angle 3 and explain your steps. So ultimately, I'm trying to find the measure of angle 3. Okay? That's what I'm trying to go to. So the information that they have given us, so all our given information is going to be right here. The measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 is 93 degrees. The measure of angle 2 plus the measure of angle 4 is 62 degrees. The measure of angle 2 is equal to the measure of angle 3. And the measure of angle 1 is equal to the measure of angle 2. Okay, so that's all given information. And they want us to solve for the measure of angle 3. All right, so I'm going to set up for my proof. So my statement and my reason. So I would always start out with basically known information that I have. So there's different ways kind of that we could go about this, but I would say I would start out with the fact that angle 2 plus angle 4 is 62 degrees, and then that angle 2, or the measure of angle 2, is equal to the measure of angle 3, because that stuff is going to lead me to being able to plug in stuff up here. So we're going to put the measure of angle 2 plus the measure of angle 4 equals 62 degrees. That's a given. Or actually, I'm going to save this one for last. I'm going to use this one first. The measure of angle 1 is equal to the measure of angle 2. That's also a given. Now, the reason I'm saving this one for the end is because I know that ultimately this is what I'm trying to solve for. Not that I can't write it at the beginning, but it will probably not help me as much until I get to the end. So does this statement up here have the measure of angle 2 in it? No. So I need to see if there's something I can do to replace my, or replace that to get angle 2, because all this other stuff has angle 2 in it. So what I'm going to do is I'm going to say that well, let me back up. Hold on. I'm going to say that the measure of angle 1 plus the measure of angle 4, I'm getting ahead of myself, is equal to 62 degrees. Okay? I'm ultimately getting to all of that, but I need to start here. Why am I allowed to say that?
Substitution.
Just happened. Yes, substitution property. Okay, because I'm trying to get rid of this, or I'm trying to get rid of angle 2 out of this because that's not in my original. That's what I was trying to say earlier. All right, so now I know that angle 1 and angle 4 add up to 62 degrees. So now's where I'm going to throw this statement in as a given. So the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 is 93 degrees. So if I know angle 1 and angle 4 add up to 62, I can take them out of this statement and say that the measure of angle 3 plus 62 degrees is equal to 93 degrees. What allows me to do that? Substitution. Now I want the measure of angle 3 by itself because that's what I'm trying to solve for. So what do I have to do?
Subtract 62 from 93.
So the measure of angle 3 is equal to 31 degrees. And we did that by the subtraction property. All right, hold on. I'm going to give you your problems in case you want to start working on them tonight because we're doing another section tomorrow. 11, 15, 19, 23, 25, and 27. And that's it for this section. You do not have to do them tonight. It is Wednesday, but I am doing 2.5 tomorrow. Okay, so just keep that in mind. If you want to get ahead.